Good morning friends. In today's lecture of Metrology and Quality Engineering, we are going to learn few of the basic concepts related to limits, fits and tolerances. Let us see what are the concepts. Starting with limits. Second we are going to see is the fits. And third we are going to see is the tolerances. Let us study one by one. Let us start with limits. As the limit, the word indicates, the limit is the terminology used to express the maximum dimension that a component can achieve as well as the minimum dimensions the component can achieve. Now when we say in terms of dimensions, there are two basic systems. The first system is called as shaft basis system and another system is called as hole basis system. Now as you can see, when we talk about assembly, either shaft goes inside the hole, whereas in some assemblies hole is being fitted onto the shaft. Now dependent on these terminologies, shaft basis and hole basis, two terminologies have been evolved. Now shaft basis says that a round circular bar or a round circular component which represents the shaft dimensions, whereas hole represents maximum space surrounded by a thickened metal part called as solid metal part, that is the hole. Over here, what we wanted to study is shaft basis and hole basis system. Moving to the next point, that is limits. If you can see, if there are number of dimensions given, suppose for this shaft, what size is required is 10 mm, or you can call it as a 10 centimeter is the dimensions required for the size of the shaft. That means 10 centimeter is the basic size required. Now, since we all know in the world of mass production and in the world of interchangeability, many times it may happen that since machines are having different variety of tools, machines are having different variety of skilled, unskilled workers working on them, there is a chance that some dimensions may go up 10 centimeter and some may come down the 10 centimeter. Now in these aspects, we have to take into consideration that there should be some allowable sizes up to which if the workpiece is made, then it has to be accepted. For example, something being in between 10 up to 10.2 centimeter and over here 9.8 centimeter. Now the components that are manufactured and having basic size up from 9.8 centimeter to 10.2 centimeter will be accepted. Now for here we have to understand two basic concepts. One is the acceptance, one is the rejection. During machining, if something goes plus minus and dimensions are in the level of acceptance or rejections, then we can call the accepted components may lies in the range between 9.8 cm to 10.2 cm. That means the components which are having permissible size is 9.8 to 10.2 cm. So that is what acceptance limit is. Beyond these, the components won't be accepted, and above these, components are not going to be accepted. Please keep in mind. Now, what we wanted to say over here is limits. Now, what type of limit shaft basis system is having? What type of limit hole system is having? Let us understand. For shaft basis system, the basic size is 10.00. That means the workpiece is have to be required basic size of 10.00 centimeter. Over here, if the component is going to 10.2 and may reduce its diameter up to 9.8, then these two are the limits, out of which this is what called as maximum limit and limit for the shaft basis system. The shafts which are made up to 10.2 cm can be accepted. The shafts which are made up to 9.8 cm can be accepted. But shafts below these are not accepted, and shafts above these are not at all accepted. Now, maximum limit for shaft is 10.2 and minimum limit for shaft is 9.8. Let us consider for the same assembly where 10 cm is the required hole diameter. Now in this case it is clear that for 10 cm this 10 cm will be valid, but for this 10.2 the shaft, the hole should be 9.8 cm, that is it should go up to 9.8, and for this 9.8 the whole side should be 10.2 cm. Then and then only assembly will be under acceptance. If not, then what will happen? If 9.8 is the shaft size and hole is having 10.4 cm, then in such case there is a skin like this, and this will be the position of the shaft. So this much amount of the space will be vacant. So in order to avoid this, the system is like that. When shaft is having 9.8 as a minimum limit, then at that same time 10.2 cm should be the whole limit, and when shaft is having 10.2 cm, 9.8 cm is the minimum limit. Over here we can write as a 9.8 as a minimum limit and 10.2 cm as a maximum limit. So these are the limits for shaft basis system and hole basis system. Now also there are another types of limit which are called as, or these conditions are called as maximum metal condition, and second is minimum metal condition. Now what happens over here is when we talk about maximum metal condition, as we all know for machining the workpiece are to be engaged on a machine, and when the tool is engaged with workpieces, it removes some sort of material. Now dependent on the removal of material, these two conditions are aligned. Maximum metal condition is the condition generally adopted by hole, we can write over here, and minimum metal condition is the amount of condition whereby shaft. Now the system may seem tricky, but it is true, because maximum metal condition for the hole, that means you have to reduce this much of the diameter. Suppose the shaft was solid shaft and amount of material has to be removed from here to here. That means more amount of material is to be removed in this segment. So we have to take much care while removing the material. Therefore, hole basis system gives maximum metal condition, whereas shaft basis, if this is the basic sign of the shaft and the shaft was like this, then we have to remove minimum metal. Therefore, minimum metal condition is favored by shaft. Now since we have seen total 4 conditions, one was maximum limit, second was minimum limit, this is maximum metal condition, and next is minimum metal condition. Moving to the second category, we are going to see is the feet. Now in feet, since we have seen limits, we know how the shaft and base are going to make. Over here we can see this shaft is going to be engaged in between these spaces, as clear. Now, dependent on the assembly and dependent on the limits, there are 3 types of feet, namely clearance feet, second interference feet, and third is the transition feet. Now what happens and what the name indicates, let us see one by one. Clearance feet, as the name indicates, it is showing some sort of clearance. That means there will be no friction, no wear and tear between the 2 feet or shaft and hole basis system. So clearance feet will indicate that easy removal of and fitting of shaft into hole or easy removal and easy fit of hole onto the shaft basis. So that is clearance fit. Next is the name indicating interference fit. As the name indicates, interference will create interference. That means either shaft will be of bigger dimension. So let us consider this as the new dimensions. And we have to make efforts in order to put shaft into hole system. So that will be interference system. And next is the transition fit. So transition fit, likewise, at the same time, the shaft will be much lesser than the expected hole size. Therefore, we have to take care that use of extra bearing system in order for fitting has to be incorporated. Then and then only the shaft will be mounted onto the hole, or hole can be incorporated onto the shaft. Likewise, there are three systems where clearance, easy go and easy come out, transition, efforts are required, and interference, there will be much efforts required. Likewise, we have seen limits and fits. In the next lecture, we will continue for the tolerance system. We have seen up till now what are the limits. Please do remember there are two systems of basic. First is shaft basis system, second is hole basis system. Shaft basis system favors for minimum metal condition, whereas hole basis system favors for maximum metal condition. Next to that was the three types of fits. Fits are the totally dependent system for the shaft and hole, whereas these three fits are clearance, interference and transition. Clearance will give easy go and out. Interference will create some sort of interference during joining, and this interference will be created at the maximum limit of the shaft and minimum limit of the hole. And transition, maximum limit of the shaft and maximum limit of the hole will create some sort of interference. Now you have understood these three concepts. We will continue the same series in the next lecture.